Hello everybody and welcome to a new Redstone showcase video. It's going to be kind of like a tutorial, but because it's more advanced and I expect more advanced people to be making this, I'm not going to go in depth with every single step of how to build it. I'm just going to take it as a given that whoever tries to build this will kind of know what they're doing and can mimic from what they see if they need to or get stuck. So, I've been watching Adrian Brightmoore. I've actually been watching his channel for some time. He is a fellow map builder and YouTuber, and he makes and does some very interesting things. And one thing in particular which sparked my interest was his crazy castle that he's developing. It's a 1.8 sort of endless, randomly generated dungeon crawler. And a keyword there is random. He's currently using different types of or looking at different types of randomizer designs, and this sort of got me thinking too on my own designs. So this over here is a very simple randomizer that I actually use. I'm actually using in one of my maps. Compact, yep. I've got a couple of limitations for this, obviously, because I want to build it in a way that he can use it if he wants to. And so I've actually got size restrictions. It has to be a maximum of 4 wide, 4 tall, and 14, and this is actually 13 here, to fit in his sort of confined crawl space area that he has. Links in the description to videos and his channel. You should definitely check him out. But yeah, so this over here, this is actually two different things I'm going to showcase. This is a randomizer. And it has up to 256 possible different combinations based on a randomizer that I'm making in my map. If we actually test this out, some random things, same thing again, give me something different. 2 and 3, 2 and 4, 2 is activating a lot. Oh, okay, and 4 and 1, yeah. So it does random stuff, and this is pretty much exactly the same, except what I'm doing is I'm outputting sort of a set, an add score, so I can actually store binary, and this goes 1, 10, 100, 1,000, bigger, bigger, yeah, tens of thousands, and so on and so on and so on, and obviously it can only fit in a 4, and it's a two-story now instead of this single-story one. The reason why it's got 3 redstone here instead of 2 redstone is how the randomizer works. It works by placing one of these 2 items in here, and then that varies the signal length. So if an iron door goes into a dropper, it will go to 2 signal length, but if an iron door goes into a hopper, it generates 3 signal length. So this had to be 3 long, or else it generated false signals. So unfortunately I couldn't save on length there, but a length was the resource that I had more of. So this can quite happily fit on the top section and the side for his thing. It's relatively simple. It's got 8 of these dropper hopper, and it is out of sync on the bottom layer by 1 by having this block, because the comparator reads the signal through. So when a signal gets activated here, as you can see, the number on the Twitch Nitro is gone, and it's random, and I can change it again. It's a different number, slightly different still. And the brilliant thing about this is you don't have to just use one type of scoreboard. You can use 3 scoreboards or 4 scoreboards, and by that I mean you can have this change the binary score by 1, and then this change the binary score by adding 10. And then over here you can have a different thing, like you could call this anything you want, and then you could have multiples. So if you wanted, in Adrian's case, he could have this control the type of this single line, control the spawners, and have 2 different possibilities, 0 and 1, let's say. And then he could use these 2 to have 4 different possibilities for like the room orientation, and he could have 3 here for 8 different possibilities, and another 2 here for another 4 possibilities. But in total, if you wanted to use every single one of them, you could have 256 possibilities, from 0 to 255. But obviously that's using binary logic and how that works. So yeah, it's quite nifty, I think. Quite random, obviously. And yeah, this is the randomizer here, and I'm just gonna zoom in over here because this is the tricky part. If you get the wrong signals and stuff like that, it can activate incorrectly. But yeah, I'm quite happy with it. It fits into a 4 by 4 by 13 here, right up to this edge. And this command block doesn't do anything. This is so I could keep this for the next part. So this over here, this is my very compact execution array. Very, very compact. And in fact, actually, I could probably make a cross-section in a second. So what happens is after this fires and you have your random number, boing. Ah, yes, that is our random number. Good. And it removed this, this over here, sets the last binary signal to 0, and then this changes this block over here to air. And this can be a relation, these coordinates, they don't have to be coordinates, they can be relative, again, to wherever this is. And as you can see now, because I've put the command into here, it's ran this. So if I actually give a quick example, because I only have this set up for a few things, and I clear this, I only have it so the first 2 of those sections work. So if I select 1 and not run that because I don't want to, I want to run this directly. Up here you can see that it says 2 because on this end, the output end, this line fired, no, not this, on top, there we go. This line fired. I have it 1, 2, 3 and 4, and then all the rest of these are just cloned. So what happens here, and I'll get to that piece of text right at the bottom here, is after this fires, it places a block over here. When the block is placed here, it activates this and this command block, these 2 on top, and they're testfor commands for a specific value in a specific scoreboard. So in this case, the binary, it could be the spawner or the location change or whatever you wanted to call the thing. And it checks to see if that is the exact value. And if it is the exact value, it goes to the output here. And you can actually have 2 outputs because this will power this block here and then indirectly power the block underneath. So you can have 2 command block outputs. And obviously this is 4 by 4, and this example here is actually the entire length. This is by 14, I think, yeah. And so what happens here is if it succeeds, it obviously outputs, and then down this line, this command block here, which is underneath, also gets activated, and it creates another redstone block next to it here, which basically sends redstone blocks all the way down the line, which is what you can see when I do this. And then the last command block is a 1.81. I'm not in the 1.8 snapshot, but it wouldn't be too difficult, obviously, for me to pop in. It's just I wanted to record this and get this out. This last command block has relational commands to clear all of these, because obviously you can select an entire area now and then set it to air. So you could select this entire back row here and clear it of all redstone command blocks, which is quite fancy. And the brilliance of this is not only can you have, it's 2 levels, so you, how many are here? 26 different combinations. So if I have this randomizer go, it can randomize outputs in different scoreboards, and then this can run all of the scoreboards by just checking the different scoreboards and seeing what the random outcome was. So it's relatively involved. I went for a command block heavy approach, other than his approach, which is using the randomization of dying chickens and such. I wanted it to have a flexible sort of number. So if he wants to just make a 2 output, he can just use this. If he wants to make 3, he can use 2 of the command blocks. And technically, if he did some fiddling, he could fit more than just this entire row here. Again, I say he should put it on the top section because I believe his bottom section has other control things. But because this only takes up one side This takes up one side, this takes up the other side. He has extra space in between, and his bottom section is left relatively clear, so this should help him a lot, I hope. If it doesn't help, hopefully it might spark some ideas. And this is a nifty contraption anyway, so I might be using... I mean, I'm already using stuff like this in my new map. It's a bit late in my new map's development to use something like this, but I certainly like this. Activate and then clear the entire row with one command block instead of there being a separate one. But yeah, should work fine. Obviously this can be as long as you need it to be. This can be more than 4 wide, but in Mr. Brightmoore's case, he needs it to be, you know, space efficient. So, at this point, you're probably just wondering, who the heck is Nemo? And my answer to that is, he's nobody. Just nobody. Kudos if you get that joke. And I will see you all next time. I hope you've enjoyed the vid. Remember to check out Adrian's channel. He makes filters as well, some which I've even used in the past. And yeah, so I'll see you next time. Bye-bye. And a little zoom in here, actually, I never showed you the cross-section. So the cross-section here is quite simple. And then you want your comparator on top. And your comparator down here. And then the second layer is command block, comparator, and I believe like this? No. Block on top of that. There we go. Yeah. So these are the 2 different intersections, just in case you wanted to have an extra look. And yeah, that's where I'll end it. Bye.